Hello and welcome to SudoKanard. We're here to solve yet another puzzle by my friend Akash Doulani from India, who provided also this quad sum Sudoku for Sudoku Grand Prix, in which a black dot means that one of the four digits is the sum of the other three. And that's it, there is no negative rule. There is, I think the variant exists with the negative rule, but I haven't seen it used in a long time. So this one was worth 70 points. I didn't get the time to solve it during the contest, and I wish I had found the time because I really enjoyed this puzzle when I solved it afterwards. So the place to start is here. We can't use the 1, so the minimum sum is with 2, 3, 4, which is 9, which is also the maximum. So this is a 2, 3, 4, 9 quadruple. 9 is not here, 3 is not here, 4 is not here. And 3 is also not here, so 3 is there. So that's the first step. With Sudoku, I'm saying that there is a 2 in there. 2, I said. So inside this quad, we can't use the 2, we can't use the 4. So the minimum value is with 1, 3, 5, which is 9, which is also the maximum. So this is a 1, 3, 5, 9 quadruple. 9 is not here. 3 is not here. 1 is not here. So 2 is here. Those are from 6, 7, 8. Those are from, so the other digit is from 6, 7, 8. And note that those are also 6, 7, 8. So we'll have to come to this part later. Here we don't have the 2, so the minimum value is with 1, 3, and 4, which is 8, and is also the maximum value because of this line. So this is a 1, 3, 4, 8 quadruple. No 4 in here, no 8 in there. And here we're left with 5, 6, and 7. So there are limitations on this. And here we can't use the 3, so the sum will be at least 1, 2, 4, will be at least 7. It could be 7 with 1, 2, 4. It could be 8 with 1, 2, and 5. It could be 9 with 1, 2, and 6. And in all scenarios, we get the 1 and the 2. So the 1 will be here, the 2 will be there. And so there are a number of options. What interests me here is that 1 and 2 are here. And this is relevant because now what can happen in here? Well, we could have 8 here with 3, 4, and 1. That would work. And actually, you can guess that it won't work in the end, because in this case, you can see that there is a deadly pattern, there would be a deadly pattern, and the puzzle wouldn't have a unique solution. This is something I noticed. So this is not an argument to prove that this is impossible, but you can suspect that 8 won't work here. I think I remember there was another reason for that. So what are the other options? Well, the other options are that this is not 8, so this is 1 and 3. And the minimum extra value here will be a 3, which makes a sum of 7. But the sum won't be 8, and the sum won't be 9, because then we would need a 5 here, and 5 is not available. So if this cell does not contain an 8, then those must be 3 and 7. And if this is 8, then those must be 3 and 4. So there is definitely a 3 in there. And the other digit is from 4 and 7. And this tells us, I don't know what it's supposed to tell us. There is a 3 in here, which is kind of interesting because it puts limitation on what can go in there. So the sum of 3 digits won't be 1, 2, 3 because 3 is not available, so it won't be 6, it won't be 7. It could it be 8? 8 won't be 1, 2, 5, it won't be 1, 3, 4. So the sum is 9 without using the 3, so it must be 1, 2, 6, 9. 2 and 9 here, 1 and 6 there. And those are 3, 4, and 8, and because 8 is there, that's the 4, and this is a 3, 8 there. And now, look, there's an 8 here, an 8 there, an 8 there, so there has to be an 8 in here. What did I do here? Oh, sorry about that. What did I do? The options are 6, 7, 8, so that deduction was not right. No, that deduction was not right. 8 is somewhere in here, but it could very well be here. All right, where do we look next? This is quite suspicious. We know that there's a 9 here. This is probably something I should investigate. So this is 2 and 9 or 4 and 9. What about 4 and 9? If I do this, then those two cells must sum to 5 without using the 3 or the 4. That's impossible. So that's not the 4. 4 is here. This is 2 and 9, so those two digits must sum to 7 without using the 3 and the 4. They could still be 1 and 6. They could still be 2 here and 5 there. So this is not fully resolved yet. And then what? And then perhaps we should focus on this. So the other digit is either 6, 7, or 8. Is that what we need to look? Perhaps 6 in here wouldn't work. If I try to put 2 and 6 here, what could happen? Not sure about that. Well, 6 won't be the sum of all 3 digits, because then I would need 1 and 3, but we could have 2, 6 with 1 here and 9 there. That seems to work. And then it would be 5 and 2 here. That seems to work. So that seems to be an option, 2 and 6. What about 2 and 7? I think I remember there was something more elegant at this point, but let's just investigate. Well, in this case, 7 has to be the sum, and those will have to be 1 and 4, which can still work with 4 and 1, I think. This seems to work, and this would be 5 and 2, that seems to work. So 7 seems to work here. What about 2 and 8? It means that those two digits must sum to 6, sorry, without using 5. They can be 2 and 4. And that also seems to work. So this is definitely not the place to look. What am I doing? Oh, already. So this is definitely not the place to look at this point. I must find something else. Something else could be this cell, or it could have something to do with that. I'm not sure about that. So let's have a look at this cell. We know it can't be 2, 3, 4. It could still be 1. It could still be the sum. We could have 2, 1, 3, 6. So it could be 6 as the sum of all digits. I'm almost certain I'm positive I'm missing something there, but let's focus on that. So it could very well be 6 in case this is the sum. In case this is not the sum, and knowing, well, just ponder what Sudoku tells us. This is from 1, 6, 7, 8. 8 can't be turned into the sum of those two digits. There's no combination that gives 8. This is true also for 7, so this is either 1 or 6. So 6 would work with 2, 1, and 3. What about 1? I'm saying that 8 here will never work, actually. 8 here, there's no combination of the other three digits that gives 8. So this is 3, this is 8. What about 9? Those two would need to sum to 6, which is impossible. So that's a 2, that's the 9. So, and now we have a 1, 6 pair together with 2 and 3. That's all there is to it. And finally, this is a 1, 6 pair here. That's not a 9. This is a 9. This is a 3. There is a 9 down there. And I'm also seeing that with those 9s, there has to be a 9 in the quad here, so that this is a 1, 2, 6. Oops. This is a 1, 2, 6, 9 quadruple with no 9 here, no 1 here, no 2 there. And perhaps we can go back to this. Perhaps it's still not the right moment. 4, 5, 7, 8. I'm not sure this is useful, actually. So where do we look? This could be the right moment. So 1 is not in here. 3 is not in here. 5 is not in here. But there has to be at least a small digit. And we know from this, oh, sorry, this is a 6, this is a 1. That's not 6. So the 3 digits here must be 2, 7, and 8. And those must be from 7, 8, 9. All right. So one of them is a 2 here. The other one is the sum of all digits, which is interesting. So the sum is 7 or 8. So that is never 6. Now we know that 6 is here. So this is also from 2, 7, 8. And 7 or 8 here will have to be the sum. 7 or 8 here will have to be the sum. So the sum is here. And the other two digits are 2s. This is how it works. So this can't be a 3. It has to be a 4. And this has to be an 8. That's the only option. So that we know finally that this couldn't be an 8, even if I already knew just by uniqueness. This is 4, this is 8. There's no 4 in here, so 1, 3, 1, 3, 3, 7. This all makes sense. This is not 7, this is not 2, so this is 9. This is 2, this is 8. This is 9. Here we get a 5 and a 7. No 7 in here, that's a 7. This is from 1 and 6. 2 is there. This column still needs 1, 6, and 5. But this row still needs 4 and 8. This 6 turns this into a 1, that's a 2. This 1 resolves all of this. One of them here is a 1. That's not a 1. This could be resolved by uniqueness, but by placing a 5 here, but I kind of vowed not to use uniqueness in solving this puzzle. 9 can only be here inside this box. I need 5 and 7 here, so 7 here, 5 there. Here I need 2, 3, 8. So 2 is here, that's 3, that's 8. Here I need 1, 6, and 4. And this is 7 and 5. 7 here, 5 there. This is 6. 1, 5, 1, 6. No 5 here. That's 5. That's 9. That's 6. That's 4. That's 9. I need a 5 somewhere. It's here. This can't be a 7, so that's 6, 7, 6. 1, 6. 7 and 6 here. 1 and 5 there. That can only be a 7. Here I need 1 and 8. Here I need 4 and 3. And that's it. So this puzzle was no walk in the park again. This was really a difficult round, a very difficult round, and the results prove what I'm saying. It was really full of difficult puzzles, but very good puzzles, I must say. This one is spectacular again, and you would expect no less from Akash Doulani. Thanks for watching this video. See you soon on SudoKanard.